Last time we saw that we can take a function like the square wave function and rewrite it as the infinite sum of cosines and sines that differ in what their frequencies are. So I think of this as taking a certain amount of various frequencies as your ingredients and mixing them together to build up to some bigger function. So the question is, how do we know how much of each of these building blocks, each of these pieces we need in order to get things to balance out right to get a function like the square wave function? Put another way, given a function f of x, like the square wave function, how do we calculate what a1 or a2 should be? This is how much of cosine of x or cosine of 2x we need in order to uh, in order for this sum to add up to the function that we actually want. Okay, so there's a formula for this, and it's this thing down here. Um, I really just want to talk about where this idea comes from. All right, and depending on which piece we're looking for, we're going to do it a little bit differently. But first of all, this a0 term is our constant term. It's how much the whole thing should be shifted up or down. So you'll notice that each of these terms, we're integrating over some range. And in this formula, the range has to do with going from negative pi to pi. We could use a different range. So if what we're interested in is what this f of x function is doing over a particular range of x values, to find the constant term for the Fourier series, we need to find what the average value of f of x is, right? So what this formula is saying is, well, if we integrate between negative pi and divide by the length of it, that's going to tell us the average value. So pictorially, our a of 0 is this middle value of f of x. Okay, so that's the constant term. For the trig components, in order to figure out what a sub k is, so the kth term, we're going to take our function and multiply it by cosine, by the cosine function that has that matching frequency. And the way I think about this is that we want to know how much this particular frequency jives with the function itself. And we're going to take the coefficients, or whatever we get out there is going to tell us what the coefficient in front of this cosine of kx term should be. It tells us how much of that particular function we want. Okay, so I'm going to switch over to a Desmos demo, and the links for all of these are going to be posted as well. But what we have here is our f of x is the function we're trying to build up to. And we want to know, all right, how much cosine of x do we need? How much cosine of 2x do we need? Cosine of nx do we need in order to add all these functions together to give us this, this square wave? Jumping back, just so we see this again, if we have varying amounts of sines and cosines and we add them all up, we can get them to add up to something like the square wave. So this is what we're trying to do. We're trying to figure out what the coefficient, how much of each of these terms we need to include in order to get to a square wave. Okay, so what I said a second ago was when we calculate something like the integral of our function times sine of x integrated over the range in question. So we're going to go from -1 to 1 in this example. But this is going to clue us into how much the function sine of x jives with our square wave function. So here in purple is the sine of x function. And to me, these look like they actually agree for the most part. And the point that I'm trying to make is this, this blue integral is going to numerically tell us how much these two functions agree. Okay, so I just want to point out sort of what this, I want to estimate what this calculation is by looking at a few points. So for each of our x values in our range, -1 to 1, so let's take this point here, we're going to multiply our function's value by the sine of x value. So here we're multiplying like -0.6 by -0.8, right? So when we're integrating between -1 and 1, we're doing this for all of the values between -1 and 1, rather than actually calculating too many of these. We're going to just look at 4 of them. All right, so the first 2 are going to be negative point something times negative point something, which gives us a positive value. So we're going to be adding up all of these things. So we've got a positive value, and then over here we've got this times this, which is another positive value, and another positive value. So when we add all of these things up, we're going to get a reasonably big thing. So as it turns out, this integral is going to indicate that, hey, sine of x actually pretty well agrees with what, or for the most part agrees with what this square wave function is trying to do. Okay, I want to contrast that with the cosine function. Okay. So if, as another part of that formula, we would want to know what, how much cosine of x we need. So we're going to integrate cosine of x times f of x dx, and again over whatever interval we're talking about. And the point I'm trying to make is that this cosine of x function actually doesn't jive with our square wave function. It actually does, it's sort of all over the place. And what I mean by that is, well, if between -1 and 1, we're adding up all of the values that we get when we multiply cosine of x by f of x, we're actually going to get a lot of terms to cancel. So again, I want to test 4 points. These are sort of midpoints. And for some of the points, we're going to have a negative value times a negative value. Just like with our sine thing, this is going to give us something positive. However, for some of the other points, like this x equals -2.5 test point, we've got a negative number times a positive number, right? So this thing is going to be negative and is actually really just going to basically cancel out with this other part. Similarly, we've got, hey, these two, a positive times a positive is positive, but a positive times a negative is negative. The terms that we get here are going to cancel with the terms that we get here. So this thing is actually going to end up equaling 0 if we integrate over all of the values between -1 and 1, indicating that cosine of x doesn't really match up with our f of x, our square wave function at all. So just in summary, let's go back to, oh, I'm still, All right, going back to our formulas here, what we do for each of the terms in the Fourier series, in order to find the coefficient, we're going to calculate this thing. And this looks messy, but what it's doing is that it's testing our function for compatibility with various frequencies. With the Desmos example, we just did sine of x and cosine of x. So these are that was finding A1 and B1. We could do the same kind of thing with testing with cosine of 2x or cosine of 3x, etc., in order to find the coefficients in front of those terms, in order to find out how much of that ingredient goes into building up to our square wave function.